Hello class. Today we're looking at different ways to solve quadratics, factoring, completing the square, and the quadratic formula. So first we're going to do a little factoring review. Your teacher might have used this as a warm-up. The first one, when I'm thinking about factoring styles, I have a leading coefficient other than 1. I have a 6 here. So I always look to see, is there a number that I can divide out of all of my terms? Something I can factor out. And I have a 6, an 11, and a 4, so no such luck there. So then I know this is going to be that kind of factoring where we're either guessing and checking or doing slide and divide. I really like this box method. So to do the box method, I'm going to start by writing a 6x squared in that upper left corner and the 4 down here. I multiply the 6 times 4 to get 24. That's my magic number. So now I'm looking for things that multiply to make 24 and add to make 11. And that's going to be an 8 times 3. So 8 times 3 is an 11. 8x plus 3x makes 11x. So I need to put 8x and 3x into my two remaining boxes. And it doesn't matter which one goes where. So now I'm going to go ahead and start factoring those out. So if I look at my first row, I have a 3x that I can factor out. My second row is a 4. Let's see, my first column is going to be a 2x. And then the 3x and 4 have nothing in common, so it's a 1. And then I just want to go through and check. So 3x times 2x makes 6x squared. 4 times 2x makes 8x. 3x, 4. So I know it's going to be 3x plus 4 times 2x plus 1. All right, on the next one, let's see, I've got to figure out what multiplies to make 9, adds to make 6. That's going to be 3 times 3, or 3 plus 3. So that means I have the quantity x plus 3 squared. And just to talk about this pattern here again that I keep discussing, I get this by taking, if I'm working backwards, right, if I'm going this way, I would first take the x and square it. That's an x squared. Middle term is going to be the 3 times x but doubled. So it's a 6x. And then my last term is the 3 squared, which is 9. So I want you to remember how I'm taking the x and the 3 and I'm doubling it to get that middle term, because we're going to be kind of working with those perfect square patterns today. On the last one, I've got to figure out what multiplies to make 16, adds to make negative 4. Or sorry, negative 8, and that is going to be negative 4. Negative 4 times negative 4 makes a positive 16. When I add them, it's a negative 8. So again, it's like if I want to go from the 8 to the 16, right, I've got to take half of it because it was doubled and then square it. This one's going to be a quantity x minus 4 squared. So really working with that pattern today. So perfect square trinomials, find the value of c that will make it a perfect square binomial when factored. So on my first one, if I think about how this is doubled, it's like an x squared plus 2x plus 2x plus something, right? I know it would factor as x plus 2 quantity squared. And so my last term would be a 4. So I'm hoping this kind of makes some sense to you. The next one, I could think about how if this is 6, that means I had an x and a negative 3 here, because negative 3 times x is negative 3x, doubled is negative 6, and then it would be squared. So my c is going to be a 9 this time. So the first one, it was a 4. Now it's a 9. Last one, do the same kind of thing, x plus 8, and then squared would be a 64. So really what I'm doing is I am taking half of the middle term, take half of the middle term slash coefficient, and then square it. All right, so another way to write that is we could think of that middle term, if we think about like ax squared plus bx plus c, that middle term, the b is the coefficient, so I could say b over 2, and then that whole thing squared would be another way to write it. So divide b by 2 and then square it. So that's because the middle term was doubled, we're dividing it in half. And then to get my last term, I need to square. All right, so we're going to do this new method called solve by completing the square. So the way we're going to do that is that the first step is going to be to move the constants. We're saying to the right side, but basically like away from the x squared. So on this first problem right here, that means I would subtract 4 on both sides. This is my example. So then I have x squared plus 6x equals negative 4. So I move the constant term away from the x squared. So now what I want to do is I want to find the value that completes the square and then add it on both sides. So I have my b term here, 6. 6 divided by 2 is 3. Squared is 9. So I would want to add 9 on both sides. So x squared plus 6x plus 9 equals negative 4 plus 9. We're allowed to add anything we want on both sides. So now I want to take the first, that first side, I guess I don't really want to call it the first side, but the side that has the full quadratic now, and I want to go ahead and factor that. So I'm going to get the quantity x plus 3 squared. On the other side, negative 4 plus 9 is a 5. So we're writing it as a factored trinomial. And I don't know if I like that wording either, because we really want to write it as a perfect square, right? I have something being squared. Then we're going to solve using the square root method. So the square root method says, hey, I have a perfect square here. I can go ahead and take a square root on both sides. So if I square root both sides, because I have a square and then a root, I'm left with the absolute value of x plus 3 equals square root of 5. So absolute value is prompting us to get both a 5 and a negative 5, or sorry, I should say a positive root 5 and a negative root 5. And on this one, when I'm subtracting 3 for both, I'm just going to get x equals negative 3 plus root 5, or x equals negative 3 minus root 5. So I got my 2 answers on that. We're going to try another one here. So on this next one, I would first want to move my constant term away from the x squared. So I know we said to the right up above, but basically away from your x squared. And then again, we want to figure out what number to add on both sides to make a perfect square. So half of 10 is 5. 5 squared is 25. And it doesn't matter negative or positive because I'm squaring it anyway. So I'm going to add 25 on both sides. And then we're going to go ahead and factor it as a perfect square. It should be a perfect square on both sides. So now on the right I have 18. On the left I have the quantity x minus 5 squared. Now because I have a perfect square, I can now square root both sides. Square and then a root makes an absolute value. And 9 is going to be, let's see, square root of 9, square root of 2. So that means x minus 5 is going to equal plus or minus 3 root 2. I really could write it twice, but on this one, like the last one, I couldn't really find a whole number answer anyway. So I could have written this as x equals negative 3 plus or minus root 5. So I'm doing it that way. You could write it twice. It doesn't really matter. And my answer is 5 plus or minus 3 root 2. So I could have solved that as 2 different separate things, right? I could have said x minus 5 equals 3 root 2. X minus 5 equals negative 3 root 2. That would be equivalent, okay? So you can kind of keep it all together or not. I don't really care. I don't care if you want to have the 2 equations to solve or if you just want to get the one answer at the end like this. So that part's kind of up to you and what makes sense. We'll see what you like in class. If it's just a number, like if I had like square root of 25, then I'd have to write 2 problems out and really solve them both. So next step is quadratic formula. So we can't always solve with completing the square. So I really like this completing the square method when my middle term has an even coefficient, like 10 or like 6. But I don't like that method if it's an odd. So another method is quadratic formula, which I know we looked at in the last chapter, but we're going to go ahead and rewrite it right here. So a quadratic formula is for solving ax squared plus bx plus c equals 0. It's x equals negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. And so again, we like to use this when b is odd. So here's the next one I'm solving. So I'm solving this one. We're going to solve with the quadratic formula. I know there's a better way, but we're going to solve with the quadratic formula. So my A is 1, my B is -5, and my C is -14. So x equals negative b is already -5, that's going to make it a positive, plus or minus b squared, so the quantity -5 squared, so make sure you've got parentheses around that -5, minus 4 times a, so 4 times 1 times -14. And this is all over 2a, so 2 times 1. So when I do this, I like to go through and simplify this and this and this kind of all at the same time. So all the highlighted sections. So 5 plus or minus 25, and then I'm going to get a minus here. And when I multiply all of those, it's going to be a negative. So minus a negative means I'm going to be adding. And 4 times 14 is 56. And so really this is a plus sign here. Oops, sorry about that. And so we are at, let's see, 5 plus or minus square root of 81 all over 2, which is going to be 5 plus or minus 9 over 2. So 5 plus 9 divided by 2, or 5 minus 9 divided by 2. So this is going to be 14 divided by 2, or -4 divided by 2. So x is going to be 7 or -2. All right, so this would have been much easier to have just factored, right? I get that. I just think it's really good to work out the whole quadratic formula with numbers so you can see how to handle that plus or minus. But honestly, we could have factored it as x minus 7 times x plus 2 equals 0, and then use zero product property. So quadratic formula is really not the best way to solve this one. All right, so the next two say solve by factoring. And this is a check your understanding. So you're going to go ahead and try just one. So try A and B. Try to solve by factoring. So that means not completing the square, not square roots, just straight up factoring. So go ahead and try that. And then you're going to come back and check your answers with me. So I think A was pretty easy to factor. Remember, when you're showing zero product property, we still want to see all the work in Algebra 2, where you're taking each of the factors, you're making them equal to 0. So make sure it's equal to 0 all the way through. That's something I commonly mark wrong. Students will forget to write an equal sign, and if there's no equal sign, you're not really solving. So I have x equals 7 or x equals -3. The next one, to factor, I want to make it equal to 0, so subtract 2 on both sides. 20x squared plus 3x minus 2 equals 0. All right, that means I've got to figure out how to factor. I can't divide something out of all of them. I'm going to go ahead and set up a box. So 20x squared minus 2, magic number is -40. So let's see, that's going to be 8 and 5. So let's see, a positive 8 and a -5. Multiply to make -40, add to make 3. So 8x minus 5x. So when I go to factor, my first row is going to be 4x. Second row, they have nothing in common, so -1, the negatives have to match. First column is 5x, and so far so good. 5x times 4x is 20x squared. 5x times -1, -5x. And then my last column is going to be a 2, and that checks as well. So that means it's going to factor as 4x minus 1 times 5x plus 2 is equal to 0. So let's go ahead and solve. Again, we want to see all the work on zero product property. Everything should be lined up. It should be neat. We should have equal signs that we're not just ignoring. Keep your answers as fractions. These are all those little details that we're looking for. So we've got x equals 1/4 or x equals -2/5. All right, go ahead. The next two we're solving by completing the square. So let's kind of review those steps really quick before you try it on your own. So completing the square, you're moving your constant away from your x squared, kind of like we did here. And then you're adding that b over 2 squared to both sides. You're factoring it, taking a square root. So you're setting it up to use that square root method. So go ahead and try A and B and then come back and check. All right, so the first one, I do want to subtract 15 on both sides. So I have x squared minus 16x equals negative 15. To figure out what number completes my square, I want to take negative 16, divide by 2, and then square it. So negative 8 squared is 64. So I'm going to add 64 on both sides. And my next step is to go ahead and factor. That's going to give me the quantity x minus 8 squared. Let's see, 64 minus 15 is going to be 49. Now we can square root both sides. So this is one I really could have just factored. That's what this is telling me. Since I'm getting a perfect square right here, I should have factored it. So now I have the quantity x minus 8 equals 7. And so x minus 8 equals 7, or x minus 8 equals negative 7. And I want to go ahead and solve. So x equals 15, or x equals 1. So we really should have factored here, right? Would have been a lot easier. We could have factored it to x minus 15 times x minus 1 right away. So it's good to know all of these methods, but we also really want to be thinking about what's going to be easiest and when. So this last one is a perfect candidate. I can tell if I move the 13 over and added it on both sides, this wouldn't have been something that's factorable anyway. And I have an even number right here. So it was not factorable. We've got an even number in front of x. This is perfect. So to figure out what to add, I would take negative 10 and divide by 2 and square it. Negative 10 divided by 2 is negative 5. Squared is 25. So really I could just ignore that negative sign, right? I know it's going to be plus for the last term on both sides either way. So I'm adding 25 on both sides. I'm using a different color so it kind of stands out. I'm surrounded by blue. On the left I'm going to factor. On the right I'm just going to combine them and make 12. So now I want to square root both sides. So I have absolute value x minus 5 equals square root of 4, square root of 3. So at this point I could write my two different equations, but I'm recognizing that all I'm doing is really simplifying the square root. And so I'm going to write it as x minus 5 equals plus or minus 2 root 3. I said plus or minus, but I kind of wrote my equals and my plus or minus on top of each other. So then I'm going to add 5 on both sides, because all I'm really doing is getting x by itself. I'm not really adding 5 and 2 root 3. I'm just writing 5 plus or minus 2 root 3. All right. So on the last three, our goal is to do quadratic formula. I don't know that we really need to do that for all of them, but we'll try. So let's see, the first one, can I factor? It looks like it's factorable, but if the 3 was a minus and the 2 was a plus, we could, but not like this. So we're going to have to do quadratic formula. So our A is 1, our B is 3, our C is negative 2. So x equals negative 3 plus or minus b squared is going to be 3 squared minus 4 times 1 times negative 2. So hopefully you've paused this, you're trying it on your own. Negative 3 plus or minus. Remember, I go through and I do my square, I do all my multiplying, and this part, that's what I want to do first. So let's see, 3 squared is 9. I have a minus and a negative, so I'm going to be adding. 4 times 1 times 2 is going to be 8. This is interesting. I'm looking at my answer key that someone made for me, and it is not right, but that's okay. Over 2, which is going to be negative 3 plus or minus the square root of 17 all over 2. So that looks great. On the next one, I would want to add 8 on both sides. So I can totally go through right now and solve. Another option is to divide everything by 2 and kind of reduce the numbers I'm working with. So I'm not going to on purpose, because I want you to kind of see how this works out. So I'm just going to leave it in there. But I don't know, it kind of bugs me. We'd really almost want to go through and factor that out, right? And then if we divide the 2 out on both sides, we would just have a simpler equation to work with. So kind of watch out for stuff like that. Hopefully your Algebra 1 teacher, you kind of remember that being discussed. And you might not. Sometimes the first time you learn these things, the first time through, it's just really hard. So our A is 2. I guess I want to use blue pen again now to contrast. Our A is 2, B is negative 8, C is positive 8. So x equals 8, because I'm taking that negative 8, making it positive, plus or minus negative 8 squared minus 4 times 2 times 8, all over 2 times 2. So this is 8 plus or minus 64 minus 4 times 2 times 8 is also 64. So 64 minus 64 is 0. 8 plus or minus the square root of 0 is just 8 plus or minus 0, which is just 8 divided by 2. So 8 divided by 2 means my only answer here is going to be 4. So 4 is going to be my only, or sorry, I had a 4 in the denominator and then it just became a 2. Now I'm the one making mistakes. So I got those mixed around. So we're dividing by 4, and then 8 divided by 4 makes x equals 2. Because this is plus or minus the square root of 0, which is 0, which is just 8 over 4, which is 2. So it's just kind of interesting, though, if you think about how I had this factored for us to start with right away. Oops, that's not what I meant to do. I did not mean to do a 0. Didn't mean to erase. If you think about taking this right away, dividing the 2 out of everything, and then dividing by 2, it's gone, then factoring, and going through and solving either with perfect squares or with zero product property. And again, like I'm screwing this up, it should be x minus 2 squared. It would have been really easy to solve that way, is basically what I'm getting at. So just because you can do quadratic formula does not mean we should do quadratic formula. On the last one, I want to get everything on one side, 0 on the other. I'm actually going to move the x squared and the 5x because I like to have them positive. I just make less mistakes if x squared is positive. So this would give me 0 equals x squared minus 4x plus 5 is what we've got right now. So let's see. That means my A is 1, my B is negative 4, and my C is 5. So let's go ahead and plug into the quadratic formula. X equals negative B, that's 4, plus or minus the negative 4 squared, minus 4 times 1 times 5, over 2 times 1. So 4 plus or minus 16 minus 20 over 2, which is going to be 4 plus or minus the square root of negative 4 over 2. And so this is where we need to know, are we solving over the set of complex numbers or not? So this is no real solution. But if they're telling you to solve over the set of complex numbers, then we would keep going. And we would say 4 plus or minus square root of negative 4 is 2i all over 2. And then remember, we could divide the 2 into both parts of the numerator, and we'd have 2 plus or minus I. So it depends on whether or not they say to solve over the set of complex numbers. And this is something that you should definitely ask for if you're taking a test and you're not sure. So you solve, you get the square root of a negative, and then you say, like, can I have complex answers? Can there be complex numbers? Or should I say square root of 0 is no solution? So we'll answer questions like that always. This is a lot of stuff today. So everything should be review from Algebra 1. I know that I have taught all of these things in Algebra 1, but it doesn't mean you remember any of them. I mean, I think we remember factoring. We remember probably perfect square trinomials a little bit, but the solving by completing the square is probably pretty rusty. Quadratic formula, we did a little bit in the last chapter, but again, probably kind of rusty. So if you need help, please make sure you ask.